Hello, I'm Chris. This is Gross Models. Welcome to part two of the Internet of Things Smart Home Starter Kit from Acebott. So, the letter that I received in this pack tells me, Dear Adventurer, my name is Lumi. When you get this letter, it means you're about to embark on a magical adventure. You can pause and read all of that if you like. I did read it all on my first video in this series, in which I built this lovely house. This is the smart home from Acebot. I put the little sticker on the front to make it look nice. But yeah, I built this all in the last stream, the live stream that I did. So if you want to see how it all came together, feel free to do that. Basically, it's just, as you can see in there, there is the main ESP32 board that runs it all with lots of wires connecting various motors, sensors, a couple of servos, a button, infrared sensor, an LED, voice recognition unit, another servo over here, and laser pointer type thing. What else have we got? A rain sensor, a temperature, light sensor, temperature and humidity sensor. As I say, servo there, button, the infrared sensor. Oh, there's a display on there as well, which you just about see. We've also got an RFID card reader over here, as well as another servo on a different door. So yes, that all got put together over the course of a couple of hours on the last stream. On this video, I'm going to be exploring the coding and operation of the kit itself and learning about programming and things with it as well. So I shall go, first of all, across to the screen and we can have a look at the book that comes with it. Obviously, it's all just like a PDF type file, which I started off. We did the adventure to save the lost city. It's not a very good story. So basically, it's just a made up story. I say a made up story. They're all made up. But you know what I mean. It's actually apparently AI generated and is a way of bringing all of these sensors and things into place. So we've done that bit. This is the board that's in there with lots of digital ports and all sorts of things on there. So the first task that we have to do after having built the house is repair the streetlight. Where do we start? The key is the sky is now darkening. There was a solar eclipse because of the meteorites. You look at the sky thinking we need to get the house running. So I have already plugged this board into the computer. But let's have a look. Yeah, we've got the battery pack as well associated into it, which is what this other plug is here with 6 AA size batteries plugged into the board to give us an extra burst of power because the servos and things can't all be run from the USB power supply. It's not quite enough. It's enough for a few lights and things, but not the whole USB operation. So yeah, introducing current and voltage, which I already know about, but you can have a look at that if you need to get a refresher. The voltage is the driving force. The current is the power, basically. So yeah, it goes from positive to negative. It doesn't really flow, but it sort of works as an idea. The LED is basically a light bulb, but it's a specific LED, blue on this one. And it can be controlled by making it brighter or dimmer, or just turning it on and off. So the Ace Code software. This is the software that I'm going to be using to program it, which is quite good. If you saw my other video in this series where I built the quadruped robot, you'll be aware of that. But let me set it up and show you what the software looks like. Right, this is the screen layout that I'm going to be using for this demonstration. As you can see, I've still got myself visible down here so we can see what happens when I do things, and the code in the window on the right there. The first thing to do is to connect it. This is connecting on COM4. So just by clicking that, then burns, apparently. Not sure exactly what it's burning. That should connect up. There we go, connected. So we now have the board connected to the computer through a USB socket. It is a ESP32 board. Now, this online mode is basically a live feed from the board itself. There's nothing to see on this one. On some of these programs, there will be stuff to use and do on this, but upload mode is what I really want. So this is the way we program it. I've loaded the program that they've supplied for this. It's built with these little blocks you can drag in and put in place and get it to do things. So, yeah, there we go. So, yeah, they snap together like that. So you can do all sorts of things. So this is built by starting the program, which is the start. It's an event. Then we're putting in a loop, which will just happen forever. And in that loop, we've got, well, 2 commands, but duplicated. We've got a single LED. How does it? Right, disconnects from there. That's how this works. Right. Okay. So a single LED, LED number 5. It all depends on this is the pin that it's being set to. So 5 is the one on the sign at the back of the house here, the one that's already on, actually. So this is going to turn LED 5 on. And then we've got another command here, which is saying wait for a second. And then we've got the next batch, which is saying turn the LED off and wait for a second. And then forever, that will repeat through and go round and round and round and round forevermore. So if I upload that to the board, on the right here, you see the actual code generated. It's a bit faint on here, but this is in C++ for the Arduino type board. Tells you what it's going to do, how it's going to do it. But basically, if you don't want to worry about that, you don't have to worry about that. You can just use the Lego blocks to build it. But I remember this for a void setup is how it initializes it. And the loop is the forever loop. LED 5, open LED, and close LED are the commands to open and close, turn it on and off. Slightly different to how it would be, and the delay is in milliseconds, so it's 1,000 milliseconds. And that is that. That is now uploaded to the board, and indeed, you can see the light on the signpost at the back here started flashing once every second. And that will continue to do that even if I unplug it from the computer. The computer is not feeding the information to do that. This program has been uploaded to the board, and the board is now running it. So that's that. I will, as ever, make a couple of changes to this to make sure I understand what's happening. So if I turn it on for 5 seconds and then turn it off for a second, that should change what happens. I need to upload that again so it understands what's going on. But that is the most simple of all commands. There we go. So it's on, flashing off, and then coming on again. Staying on for a long time, 5 seconds, and then turning off for a second, and coming back on. So yeah, the most simple control always seems to be the thing with these to start off with, just to teach you basic controls and basic coding. So that is what that does. The manual editing section over here, I'm not entirely certain. I think that's just for writing your own code into it, but the auto-generated code is obviously designed from that. So that's what we've got. That is how that's going to work and what's going to continue on from that. If we go back to the main screen, I've done that. I've got the lab program. Then it talks you through what's what. It talks about upload mode and tells you what's going to happen. So step 2, give the street lamp wisdom. Let the street lamp learn to breathe. So we're going to make it a little bit smart. So what we're going to do is just change the intensity of the light with PWM, pulse width modulation. There we go. It is a different duty cycle to simulate an analog output. So we've got a different information on there. The single LED, we're setting the brightness. and we're changing the brightness. 0 is off, and 255 is obviously on, as bright as it goes. The duty cycle. Okay, so yeah, that's changing it. How do we code? So that is the code, which I shall get loaded up in the software. We'll have a look at that and see what's what. So here we have the program running, or not actually running yet, just loaded up. So again, we're starting the program. We're setting the lightness to 0. Set the variable lightness to store the brightness. So that's the output. So we're just giving it a name. We're calling it lightness. And then we're setting up a loop. So we're repeating this loop until the lightness is maximum. We set the brightness of the LED to the number in lightness. And then we're changing the lightness by 5. So we're just increasing it by 5, waiting 0.02 of a second. Then we're looping that little bit and increasing it by 5 until it gets up to 255, in which case it will skip past that arrow, go down to the next bit, and then it's repeating until the lightness gets to 0, and we're setting the lightness by -5 every 2 seconds and repeating that until it gets down to 0. So we're going to set lightness to nothing, so we turn it off, and every 100th, 50th of a second, we're going to increase it a little bit until it gets fully bright, and then we'll decrease it until it gets fully off, and then we'll start again, increasing it and decreasing it. So let me upload that. The board is still plugged in and everything. Let's have a look at the actual code for that. It's a more complicated one, obviously. Set the variable lightness just by saying lightness equals 0. Set light. Yeah, I'm not going to be looking at the code too much on this because it's already getting a bit beyond me. But yeah, delay, I understand the delay. Lightness plus equal to 5. Yeah, I can vaguely understand most of that, but not fully. I'll understand the Lego block bit a little bit better. So now that is up and running, and indeed you can see the light brightening and dimming, flashing off and turning on again. So yes, that was the next step to the light. Very, very understandable, clear, concise, and exactly what I expected it to do. Let's go back to the screen, and it will tell me to download the lamp program. Yeah, brightness of the street lamp gradually increased, then gradually decreased, exactly what I wanted. So task 3, let's add a switch to control the light. Street light keeps flashing. How can I turn it off? We can put a button in. So yes, I've seen it. I don't know how to use it. Right, the button, it tells me about a button. Basically, it's contact that you can make that's sprung, so you can press it, or when you release it, it's not made. Input and output. Yeah, about input and output. We input, digital output. The different pins on the board, but we can understand that. That's fine. So it's going to be more and more to learn. It's also going to be more fun. Right, let's load up the software and see exactly what it tells us. Okay, here we go. And this is the code. We've got, again, fairly obvious, except one extra detail. We've got flag. Establish a variable flag to store the state of the LED, whether it's on or off. If it's 0, it's off. It's on. Makes sense to me. So we're setting it to off to begin with, and we're turning the LED off. Okay. And then we've got our loop set up. So if the button is pressed, then wait until the button isn't pressed, till not the button is pressed. And then so basically, button is pressed, just sit there and loop that bit, I assume, and wait for it. If the flag is 0, if the LED's off, turn it on. And turn the flag to on. Right, yeah. Otherwise, keep it off and set it to off. So if the button's pressed, turn it on. If the button's pressed, turn it off. So it should work if I press a button, comes on. It doesn't do anything while the button is pressed. It's only when the button is released after it's been pressed that it turns it on and turns it off. So yeah, it's not as simple as while the button is pressed, turn the light on. This is actually working as a switch, which I understand, and I figure that bit a little bit. The code itself is well beyond me. It's got lots of different things in there, integers and things. I don't know what the E68891 business is. I don't know what that's all about at all. Um, yeah, ABC button. Yeah, I would like to understand that, but I just don't. But I understand the Lego bit of it. Um, so yeah, that makes sense to me. Is he going to explain it to me a little bit more? After uploading the program, the following effects will appear. Press the button, the LED will light up. Press it again, it goes off. I know what that works. Not going to tell me why. No. Okay. Add eyes to the street lamp. If you finish the repair, right in front of you, figure out that particular component. This is a PIR. It's a human infrared sensor. I can't remember what PIR stands for. Does it tell me? No. Something infrared radiation, probably. Heat emitting object enters the sensor's object detection range. Okay. Only outputs corresponding electrical signal when external radiation causes a change in the temperature's own temperature. Right, so it's sensitive only to moving human bodies. Fair enough, okay. When a human body is sensing outputs a high voltage signal has a certain delay time. The human body remains within it, continues to output. And when it leaves and the delay ends, will it go back to low? Okay. Coding approach is similar to that of the button module. Gather information from the sensor, detecting whether anyone's nearby. If it gets movement, it will turn it on. If it doesn't detect movement after a while, it will turn it back off again. So yeah, let me load up the next part of the software, the next program. There, find it all now. Right, I shall find the next bit of the program and get it loaded up. Right, the software is installed and up and running. It makes more sense to me than the other one. This is just a simple loop. If the motion sensor is 1, if it detects movement, turn the light on. If it doesn't detect movement, turn it off. So you can see the light on the board there actually coming on occasionally. The sensor is just up there, and there is a red light under that as well, which you can hopefully just about see. Let's go to a bigger view. When that light comes on, tells it to turn the other light on as well. So it's off. I'll move around, text me, and it turns the light on. Turns it off after a few seconds. I understand it. I like it. And it makes sense to me. I can figure out exactly why that's doing what it does simply from that instruction set. So yeah, that one is easy for me to understand. I don't mind that one at all. Let's see what they have to say about it quickly. Nothing. Just say I've made it. Secret in the light is the next part, task 5. It's going to use a light sensor as well. The light sensor. The light sensor is a device that determines the environment is light or dark. And technically, it measures the amount of light falling on it, the intensity of ambient light. Yeah, that's okay. It uses the resistance in it. It's a variable resistor. The intensity of the light is not just light and dark, it's a continuous state. Talking about digital and analog. Yeah, it's neither on or off. It's an analog signal. It can be on in various degrees. That's okay. Changing the input data on the light sensor. In online mode, you can store the input values in the light sensor in a variable and display the variable on the stage. We shall see how that works. Let me get the software loaded up and we'll see. Let me see if I can do that on the fly. Get that loaded up. There we go. It's opening that. I'll move that out of the way because we'll be looking at that on the actual screen so you can see what's happening there. So yes, there we go. We've got, all we're doing is reading that. So let's open that up. Open that up. There we go. Come on. Not liking it. It's because I've already got the software open. Let's shut the other version of that down. There we go. Because when I click on the file, it opens it up. So there we go. This is now installing software into its memory. And the light sensor is over here. Which I think I need to upload it first before it will do anything. So the software itself is when clicked. I don't know about when. Oh, when go is clicked, right? Forever. Set the lightness on the light sensor. Set the lightness to the light sensor. 32 is just where it's plugged in. Okay, yeah, I know, I understand that. So I didn't need to upload it because we're actually doing it in online mode. When I click go, that is now running the code on the board, and the board is looking at this light sensor and displaying it in that window that says lightness, which hopefully you can just about see. Let me make sure that's coming down. Yeah, the lightness box just there, going up to 3200 and down to 500 under the nice bright bench lights. So that's given us a reading on that. So I would assume that we're now going to end up using that in conjunction with the LED to brighten it or dim it. Let's have a look and see exactly what that tells me to do. That. Yeah, so we've run that. And yes, as I just showed, it's doing that on there. Good. It's dark and someone please light up. Let's get that software up and running. Dr. Lumi, raise his arm. You are using the PIR, the light sensor, and the LED. Okay, that makes sense. So sounds complicated, but it's not really. Final instructions will be given to the main control system. Yeah, let's have a look. We've got this. So we've got detect whether there is anyone. State the value of the light sensor. If greater than 2000, then determine it's night. Yes, so it's basically if two things are true, then turn it on. If they're not true, turn it off. So if there is somebody there and it's dark, turn the LED on. That makes sense to me. I understand that. Let's just click the run button on that. Or do I need to upload it first? I think I need to upload it first so the board itself knows what it's doing. And then I can get the information from it in the live mode. See what that says. So let's get that loaded up. Upload. I clicked it. I clicked it too soon. You need to let it upload before I go off of upload mode. So right, I'll get that loaded up and then we'll have a look. Okay, so we've got that running. Let me go back to the bench so you can see exactly what's happening. We've got the light sensor detecting the light level and the PIR detecting movement. So they should work independently. Actually, let's go back to the code. Let's try going to the online mode. We got click go. Go. No. For some reason, that's not doing what I thought it would do. I thought that would run and show me the code there, but it's obviously not designed to do that. Not sure. I think I've broken it now. Not sure why I've broken it now, but let's try uploading it again just to see. We'll go back to the bench and have a look at it actually working. The moment the light's on, it's still uploading. Flashing to show data's transferring, I should think. The 100%, the upload is now complete. The light is off. So if we've got movement, the light doesn't come on. Right, I'll wait for that light to go off. Then movement, the light doesn't come on. If we put it into darkness, for that to go off, it's dark, the light doesn't come on. Movement and the light, darkness, it's on. There we go. Nothing. But when it's dark and there's movement, the light comes on. And then when it gets light goes off. Both have to be active. I understand that. That makes perfect sense to me. I fully understand how that's working. So yeah, I get that. And we could change the thing round. So if I made that 0, upload that, then that should work in the opposite direction if my brain is calculating how it would work properly. So when that's uploaded, it should have the light on unless there's movement, I think, in the dark. So now when it's dark, the light comes on. There's movement, the light goes off. And if they're both off, then if it's light, then it will never come on. As soon as there's not movement, it gets dark, the light comes on. Yes. So by changing that, I made it work in completely the opposite way. Well, not completely the opposite way, but in enough of the opposite way that I understand what's going on with it. So movement and dark, no light. Yeah. Yes. Not very useful, but I understand how that works. So yeah, let's continue on. You've discovered a mystery. Sensor is like our human senses. Sensor can only pick up one type of signal. Yes, that's why we need to understand so many different kinds of sensors. What's next then? Test whether the shield works properly. Where is the shield? Right. Yes, this is the laser module. This is one that I haven't used before. I haven't played around with laser modules before. But it's a 650 nanometer red laser diode. It produces a red dot laser beam. Don't look at it because it will hurt. It's basically a laser pointer controlled by a pin. How do we test if the shield works? We'll turn it on and off. Okay, so we'll get that code uploaded and we'll see how it works. Now, this does have an interesting effect, as you can see on the screen there. It's got different things happening depending on the ring that it's looking through. I shall show you that in just a sec. Right, there we go. This is now, again, back to fairly simple coding. We're starting the program. We're forever doing a loop of turning the laser on for 5 seconds, turning it off for 1 second. And as you can see, the little red dot there is the laser going on and off occasionally. Now, when I was building this, I thought it was being built up strange. This blue tube doesn't actually connect to the initial laser piece. And I thought it didn't do anything, but it does actually do something. What it does is enable the LED, the laser, to shine through this plastic disc. I've just taken off now. So yes, it shines through this small plastic disc, which looks like a transparent disc, but in fact isn't. It does have, oh, you can see the laser shining through onto my fingers there. So yes, it does indeed have things on it, rather in it. I'll show you how I can show you. It's projecting, basically. So yeah, let me unplug that. Don't need it plugged into the computer for doing this because it's self-powered. So yes, that LED is actually shining through that disc, and that disc is refracting very slightly. So let me see how I can show you how that's working. Hopefully I can point it in the right direction. You can see it doing things. You can see the dot there, but you can only just see the dot. Let me try and set this up in the dark a little bit, so hopefully you'll be able to see what's going on. Right. Yes, there we go. By holding this upside down and pointing it at a white piece of paper, you can see it actually diffract, diffract, refracts it into a picture. If I turn the disc around, it changes to a different picture as well. So we've got very Christmas themed, which is good for this time of year. Tree, a snowman, and a little bit more. What we've got there? Canes. The Christmas is that? I can't quite tell what that one is. I'm too far away now. Got a thing that says Xmas backwards. I've obviously got the ringing upside down now. So let me turn that over. There we go. Let's try that again then. Yeah, Xmas, it says on there. If I come back of it, it makes it bigger, but not quite so bright. The distance just right to make it look right, but do that. So yeah, interestingly, the laser itself is not anything special. I won't try it directly at the camera because that will make things go wrong. But it's going through that disc that makes it actually display something. So yeah, I understand how the code works, and it does exactly. I just said I wasn't going to point it at the camera. I just did. Yeah, so that makes sense. I understand how that works, and it's an interesting addition. Right, so there we go. The shield is not damaged and can be used, so everything's okay in the world. Now I have to repair the mirror, the time mirror. The secrets of the time mirror. Yes, so this is the big mirror that's on the side of the house there. Looks like a normal mirror, but it isn't. Now, if you didn't see me build this, let me go back to the bench and show you. This is the time mirror. On this side is a two-way mirror or one-way mirror. It's a mirror that's only partially reflective. The other side is a solid mirror, and in between are these rings of wood which do have an RGB strip light inside them. So it creates an infinity mirror. So we'll see how that works. It says, oh, it's got more stuff about LED strip. Yep, this is what we've got. Each lamp contains different colors, so we can set it to basically any color you like. Difficult to fix the mirror. Don't know how to mix the colors. Right, principal optical colors, RGB, different amounts of red, green, and blue will make different colors. Sounds simple. If we set the parameters like this, yeah, it means setting all the LEDs to red, like that. Sets them all to green. Yeah, understand that. So you can change the brightness of different things. So let's upload that, and we'll see exactly what it's going to do. Uploading progress. So the RGB strip is on pin 16, basically. We're setting it to 000256. That the brightness of all of it. Third LED. First number then. Wait, what? Why are there four numbers if it's just R, G, and B? 0. What's the first 0? 0 in the first box represents all the LEDs on the strip. Specific number for specific LED. Right, okay, there we go. So that has now come on and is showing us the infinity tunnel, which is pretty cool, isn't it? I do like that. It's deeper than the house itself is. So that is that by setting the blue to 256. So what I will do will be to change this coding. Let's change that to 255. And then, right. Yeah. And that 0. And then we'll set that to by 5. So we should have, let's make that, let's change it all up, shall we? Let's change that to that. So we turn them all on, then we go red, and then can I copy these? Is that how it works? No, that moves it around. There we go, duplicate. Bang. There we go. And we'll duplicate that again. Put that down the bottom. So what we're going to do, get rid of these comments because I know what they are doing. I'm going to put that to 0. And I just that. I have to type it all the time. It's easier for me to do this. That in there. Put that in there. Put that to 0. So if I'm correct, it should go white, and then it will go red, green, and blue. Then back to white. So let's put in one more of it turning off first, which will be turning them all to 0. Okay. So I'll upload that, and it should automatically change it. If I'm correct, it should go white, red, green, blue, off, white, red, green, blue, off. Let's have a look and see what happens once it is uploaded. There we go, red, green, blue, off. So my understanding of the coding does work. So I could probably, and I think I will, play around with the coding briefly offline and see if I can change it between the two using a combination of that breathing thing. So let me play around with the coding, see if I can figure it out, and then see if I can show you how it works. Right, I have written my own program. As you can see here, I basically copied what they did, but changed some things up. So I've got the RGB strip instead of the LED from the first one. And I've made my own variable called color, which I've set to 0 and then set a mini loop, changing every 10th of a second. I can make that quicker than that. That needs to be quicker than that. So let's put that to be 0.02. Yeah, let's have that much quicker. 0.02. So yes, what this is now doing, and actually I'll change that to red so we make sure we know that it's working. So what this will be doing while I'm uploading that is basically turning the red up until it gets maximum, and then turning it back down again until it gets to minimum, then turning it up again. So we'll see how that looks once that's uploaded. That should start running straight away. There you go, it's red, and the red is flashing on and off. What I would like to do would be to have it cycle through colours. I don't know. I can do that by playing around with different variables. I'm going to need colours for each of them. Have them changing at different rates. So I'll have a little play around with that as well and see what I can come up with. Something I'm sure I can get some interesting pulsing effects. So let me play around with that, make it a little bit more complicated, and we'll see how it works. Okay, after a bit of faff and figuring out, I've worked out how it works, and I'm sure there is a better way of doing it, but what I have done is set up 3 variables, C1, 2, and 3, for the 3 colours, red, green, and blue. I could have called them red, green, and blue, but I didn't. So I've got the breathing working for C1, increasing it by 5 every 0.001 seconds, and then going down to dark. And then once that's done, it will do the same for 2, and then the same for 3. And how that actually looks is like that. So we've got red, green, blue, red, green, blue, fade, flashing in, flashing out fairly quickly. And yeah, I understand the principle behind it and why it's doing that now. So I'm happy with that. I would be happier to have it perhaps not going down to black every time, but I could tweak things so it doesn't go down to nothing. But I understand how that works. In fact, let's try that now live, just to see what happens. So instead of going down to nothing, we'll change that so when it gets down to 50, and we'll change all the others as well to be 50. So it won't go down to black, it will just go down to dim. So let's change all of those to 50. If I now upload that, see what that does when it goes through 25%, 30, 40%. It stops running because it's obviously busy doing other things. And 100%, there we go. Yes, that's changing the colors because it's not turning them off. So it's not quite as blue, quite as red, or quite as green because it's got a mixture of the other colors still in it. So interesting, but yeah, I understand why it's doing that. So that's always good. So that's more of a color change, which is what I was after originally. Just got there accidentally. So, as he says, great time mirror restored. We are back to having the time mirror working and working in ways that I'm happy with it. I understand the color change now. I could have it better, but I'm quite happy with that effect actually. So I quite like that. Not that it's going to do that forever because I'm not going to use this software forever, but I understand how that works and can use that in other things with other lights and stuff anyway. So let's go on. The next step. It's starting to rain. It's raining, Dr. Lumi. It's raining. Come on in. Test our raindrop sensor. Helps us monitor rain conditions. Okay. How does it detect rain? Right. This is, as far as I know, the bits on it are just basically like open circuits that will detect resistance across them, which water will produce. Yeah, when they're laying between the electrodes form a conductive path, resistance value changes accordingly. Yeah, that's that. So that is going to make our window shut automatically. So we're going to use the servos for that. So the main structure of the servo is shown. Several parts: shell, variable speed, gear set, motor, adjustable potentiometer, control board, steering wheel. So that's how a servo works. It's basically a motor that's got electronics inside it. So the code for when it rains is here. Setting the servo angle. Right, I have already reattached the nuts, the cog on there. I shall show you. Basically, just screwed that onto there where it should be. I've made sure it's in the closed position when I did it. So it's all zeroed and set up properly. As that says it should be. Closed position. So yeah, let's upload the code. Let's have a look at the code and then see what it does and upload it and see how it works. So the code itself is here. Let's get that connected to the board again before we have a look at it. So set the servo to angle 123. That's the open window angle. Angle 40 is the closed. So yeah, if the raindrop sensor detects, it's similar to the light sensor. If it gets a certain number, then set that to 40. Wait for a second, and if need be, set it back to 123. No worries about intermediate stages. It's either that way or that way, and the servo will automatically switch between them. So that is that. That should now be installed and uploaded. Something's definitely uploaded because I've got the lights have just come on in different format. Strange. I don't know exactly what that means, but there we go. That's what that's come up on there. The window is shut, and this is the rain sensor on the top here. So if I lick my finger, I'll be doing anything. Something's not right. Let me try uploading it again, make sure everything goes through okay. I may have upset it by moving the screen around while it was uploading. I think it doesn't like that. Make sure that's dry. Get it uploaded once again. 51%, 52, 53, 60. It's getting up there quick. Disconnected. Disconnected. Make sure that's plugged in. Try it again. Please connect the device first. Upload. The connection might not be the best onto the USB, so I'll do it without picking it up. No, disconnect. Let me figure out why it's not working and come back to you. Okay, I plugged it in and unplugged it a few times, and it seems to be working properly again now. So we'll see the window is open. I wet my finger and touch the sensor. It closes because it's detected rain. If I wipe that away, detect no rain. Hopefully. Eventually. Not quite dry. There we go. Once it's properly dry, the window opens again. Yeah, it's exactly as it should work. Closed. And open. Nice. So yeah, we can adjust the tweaks, the settings on that. That should actually probably open a little bit further than that. So maybe I've got one tooth out on that. So let me tweak the code. So 1, 2, 3 is the open window angle. So let's make that a little bit more than that. Oh, well, there we go. Make that 135. 40, the close did seem to be about right. So let's try that. Oh, connect the device again. That should now open it a little bit further. Maybe that's because of how I had it programmed together. We'll see what that works. You can tweak the raindrop sensor setting as well if I need be. So one there. So let's have a look. That is now open just that little bit further so they can actually see the edge of the window in there. And it closes like that. I'm happy with that as being a closed position. That should open it again once it dries off. Come on. You know you want to. Let's dry. There we go. See? Nice. So I understand how that works. I understand the logic behind it, the program behind that. Nice and easy. That makes sense to me. So let's have a look at the next bit. Most important part of a smart home. What's the most important part? The living conditions. Living environment is important. Temperature and humidity. So we monitor them. That's the next block along here. So the final one that we haven't used on this set, we did that. We did the button. Just done that. We've done the light sensor. This is the temperature and humidity sensor. So that is the HT11. Digital temperature and humidity. Converts it into that. Temperature range 0 to 50. Accuracy plus or minus 2 degrees. Humidity 20 to 80. Okay, temperature humidity can't be seen with the naked eye. How do you know? So this one, we pass it into a variable, and then we can show that. Since there's complicated usage, it's quite simple. Print the sensor values in the serial monitor. So, right, let me get that loaded up, and then we'll have a look and see what it says. Okay, so this is the program. We've got the normal start the program, a loop forever, serial print the temperature, and we're going to print humidity. What's humidity? Humidity and temperature sensor. So we're going to get from that, we can get temperature or humidity. We're just going to print that. Wait a second, print the humidity, print that. So we're getting the humidity. How are we getting that? What's that? Where are we getting that from? join temperature. I don't know what the join bit is. Okay, I don't know where it's getting that from. I know it's getting it from there, but I don't know if we're just calling it humidity. Seems to be the way it goes. So let's upload that. And then we should have the serial monitor on the corner of that. We'll, once it's finished loading, start displaying the information. So we've got humidity 55, temperature 23.5, 55, 23.5. Neither of those are likely to change at any time soon. I could get the temperature to go up probably by putting my hand over it. So it's got a big plastic here, 23.6. There you go, 23.7, 23.9, 24 degrees. And that should probably continue to go up for a couple of seconds, but then it should slow down and start going back down again, probably. 24.4, there we go, it's settling down. And no, it's still going up, just going up much slower. 24.5. 4, the humidity went down a bit. Blow on it. 24.4, there you go. So yes, it is measuring the temperature and humidity and just displaying it on the serial monitor, which in itself is not ideal, but it means that we know that the sensor's working and it's all coming through as it should. So yeah, that's okay. I'm moderately happy with that. I understand how that works. Back to the screen to see what's next. Next is making the temperature humidity values similar, visible. Yes, because we haven't shown you this yet. This is on the other side of the house. You can't really see that until I hold it like that. Got a screen on the bottom there, an LCD screen. So we'll learn how to program that. It's basically a library, and then we can just tell it what to print on it. 16 characters on 2 lines. So yeah, how do you in LCD? We can get it to display the things. So let's grab the software, program it up, and see what happens. Right, so we got the software up and running. Let's show you that. There we go. Nice and easy. It just says what we need to do. Let me get the window so you can see it. There's no more to see really on that. We're running a loop every second. We're updating it. Not sure about the X and Y. That's obviously the position of it. So we're just putting it on the first line. Join. There's obviously 2 things that we're showing. We're showing T and showing the temperature, H and showing the humidity. And that in fact looks just like that on here. As you can just about see on there, I think. We've got T 23.5, H 54 showing on that screen. And that's updating every second, which is often enough for the temperature and things to update. Yeah, not really a lot I can change on that to show it in any different way. I could change the letters being shown. I will make a change. I'm going to see if I can figure out and get it on the second line or get one on each line. So let me play with the code, see if I can understand how that works, and then show you. Okay, in my first attempt at this, I've just duplicated the line and changed the Y value to 1. So that is actually doing what I thought it would do, is printing the same thing on both lines. So that makes sense to me as to how that works. So what I will do now will be to change that. I'm going to get rid of that bit. How that works? I don't know what that bit is, so I'll get rid of that as well. So that's that, and then I can get rid of that bit from there as well. Don't know what that is, so I'll get rid of that. No, I can't get rid of that. I don't know why it says high. Not entirely certain what that does. Okay, that didn't do what I thought it was going to do. So I'll put that back down there. We've got temperature I don't know what these join things are. I'm going to change that to humidity. Capital H, because that looks nicer. And this will display humidity. So hopefully that will do what I want it to do. So it should show temperature on the top and humidity on the bottom. Upload it and see if I haven't broken it completely by not knowing what I'm doing. It could go either way with this. Let's have a look and see. It's still writing. It's 61%. Something's happening. Gone. It's uploaded. What is it actually showing? It is. It's working as intended. Temperature on the top, humidity on the bottom. It's easier to read like that. We've got 2 lines. Why not use them both? And in fact, we can change that now to show not just T plus. We can show. You can actually have it say temp and and I'm gonna add a 1 to that as well. Put 1 on the first, so the temperature the temperature will have to be 0. I'm going to make that a 1 to shift that across to the right a bit. I don't know how much. So by doing this, we'll see just how much 1 is. I assume it's 1 character. So I'd want it more than that to get it in the middle. Temperature is a longer word, so that's going to be more across the middle anyway. Let's see what that says. Notice I've got the wire sticking out the top there as well a little bit. Right, is that uploaded and changed? Yes, 1 character. It's shifted across. It does just say temp and does say hom. So to make that look even nicer, what I will do will be to shift that across. What have we got across there? 3. Shift that one about 5. 4 will do it. One more than that will do that. So when that's finished uploading, that should shift it across to be more central on that display. It's uploading 48, 49, 52. There we go, getting there now. There we go. That looks much nicer, much more centered and displaying quite nicely. I like that. Good. I'm happy. I'm happy with that. It's working as intended, and I understand how it works, which is always good with these things. So that's that. The LCD screen is not displaying information, so the blue knob behind the LCD screen with the screwdriver brightness. I could do turn it down a little bit, but I'm leaving it as it is now because it's assembled. Right, the rain has stopped. Start repairing the gate of task 12. The other servo. So yes, I've already reconnected the cog onto that as well, but we've got to do the RFID. So yeah, let's read about RFID, radio frequency identification, technology that's used in credit cards and stuff now. The contactless idea is the same thing, as well as many sort of car parks and things like that. So yeah, in the software itself, we'll have a look at in a moment. But the hardware, we've got obviously the board is behind this sign on the side there, and we've got our little key fob, which I assume is programmed with something. I don't know. I didn't have to program anything with it, unless it's going to tell me to do that in a moment. Small chip contains a unique identifier, usually a numerical code. So yeah, when it reads it, it activates tags. Makes sense. When the RFID senses the blue keychain, it opens the door. You refer this to this code. Right, so we've got a code there, which we'll have a look at and see. I've already reconnected that. So let's go at the code and see what it says. Right. Again, I sort of understand the coding on this. We're starting the program, obviously, as ever. Setting the servo, the different servo. This is the 18, the door, so angle 5. We're getting an ID. We're telling it what type of ID it is. It could be, numbers, but it's a string of numbers basically. We're setting the ID to the RFID, reading the ID. So we're reading the ID. If the length of the ID is anything, then open the door. We're going to print the ID on the serial monitor, although I can't seem to get that bit working. And we're getting the door to open by setting that to 120. Waiting 2 seconds and then closing the door again. So as that works on here, we've got, let's unplug it. So just got that there. No, something's not right with that. Right, I have found, as well as the key fob that came with it, I've actually got other ways of doing it. I've got another key fob, which apparently not working. Although maybe I have to reboot everything. Let's try again. Let's get that uploaded again. Right, so yes, I've got a key fob. I've also got a card, and I've got another pack with exactly the same things in it. It's got a bigger version with multiple pins. I think this can do writing as well as reading. And I've got another card and key fob, exactly the same description. So I'll try those again in a moment as well. Once it's finished uploading, see what that's doing. It's finished uploading, so let's try the original one again. That works. There we go. And it's actually working on the serial bit now as well. It's showing 2C588. That should be the same again. Yep. We've got that one. There we go. 1E, the card. Give me 83. That one gives me that. And the other card gives me that. So yes, I've actually got 5 different ways of unlocking it, and they each give a different code back. So I could program it to only open that with one of them, and I can probably program it to open the window with the other. Let me see if I can program it myself to do that, and we'll see what happens. Okay, first step in trying to understand this a little bit better, I've changed the settings, so now the ID has to equal that code, which is one of the codes I got from one of these key fobs. I think it's that one, but I'm not entirely certain. I've uploaded it. We'll see if that works. Yes, so that one opens the door. That one does not open the door. So now only that one will open the door. So as a security setting, that works better. So now what I need to do is to... yeah, that one's actually not showing up as anything because it's not, which is fair enough. That's good. Now I need to change the programming, so if it equals that one, I'm going to open the window. So I need to figure out what the other servo is, figure out what the code for that is, and sort it out that way. So I shall be back in just a sec. Right, I've figured it out. I've still got a couple of loose bits floating around there where I had things open. I'm not sure what the Chinese characters are, but anyway. So what we've got, get rid of a lot of this because that doesn't mean anything anymore because I've changed things. He's still giving the remarks to things. Different now. So yeah, what I've done is basically copied that section. So we've got the if the ID equals that particular code, then print that code and print and set the servo 18 to 120, 2 seconds, then close it. If it's this particular code that comes in, then print that ID, open the window to that code, and then close it. So if I do that from here, that one opened and closed, and this one, that's that one open and closed. I know you can't see it. I shall tilt things so you can. So you've got the door there. That one opening. Not opening with that one. But what is opening with that one is over this side. Window. So yes, I'm happy with that. What I am going to do is change it up a little bit further. So I've got the card that isn't actually telling me if anything's working or not. So I'm going to see if I can change the thing on that to say if anything else happens, then print access denied or something. I'll see if I can figure out how to do that on the serial monitor. Okay, I've had some playing around. I've got some power issues with it, I think, but I did manage to get it working most of the way. I've got it so that one will open the window. This one will open the door. And this one won't open anything. But when I've got it connected to the computer okay, it flashes up access denied when I use the card that's not either of those two. Unfortunately, it still does that when I use that one. When I use that one and take it away, it then says access denied. I'm not entirely certain why that is. I know why it is, but I can't do anything about it. It's beeping at me saying it's not connected, although it is. So I don't know exactly what's up with that. But let me unplug it for now. Yeah, so I've managed to get this to say gate open and window open when that certain things happen. But when it reads 0, or when it doesn't read 0, it says access denied. That's the only way I could get it to do that without it. Otherwise, it would just say access denied all the time when it wasn't reading a card. So now when it reads anything, it will say access denied after it's done the window open thing. So I don't know how to stop it doing that. I should be able to set up a bit in here that's like, so when the ID is not 0, or when not the ID equals 0, seems to be the long way of doing this. There's no simple thing. There's equals to, but when there's not a not equals to, which would be the ideal thing. But I can't seem to do that. But I'm going to give up for now because I've had enough looking at it. But it's working as intended when I've got enough power going through to it. I think I need better batteries. But we'll figure that out down the line. So that's that for this. I'm going to continue on to the next step and see what that's telling me to do. So here we are with task 13. The Guardian Shield has been launched. We finished the repair testing, so we're doing voice recognition now. We're getting a little bit smarter. This is the bit in the tree that I built, which has got a speaker and a microphone in there. The voice recognition module, an AI offline speech recognition product. Basically, it responds to the wake up word, which is, let me just make sure you can hear it when I talk to it. Hi, Lumi. Hi, Lumi. You probably didn't catch that. Let me move it to closer to the microphone so you can hear her. Hi, Lumi. Let me just check to see that that's coming through. Right, I think I've got it working now with my external microphone. So we'll just see if this can be heard okay. Hi, Lumi. Hi, Lumi. Hi, Lumi.
Hi, I am here.
Okay, let's see what works. Turn on the laser. No, it doesn't like that. Open the laser.
Okay.
See, that works. Turned it on. Close the laser.
Okay.
For some reason, it doesn't like turn on and turn off. But open and close, it seems to be okay with. So, yeah, that seems to be good. We'll figure that out as we go on. So we have several things that you can do. At the moment, it's just the laser, turn on and off the laser. Just 10 and 11 set up to work. In the software, which I shall show you again momentarily, we're just looking for those two things. The voice stuff is all pre-baked into it. So let me show you that down here. As I say, the voice stuff is all pre-baked into the chip, as far as I can tell. So we're getting the instruction value from the voice recognition module. I don't know about the RX and TX. I'm not sure what they are, if they're receiving and transmitting normally, but yeah. So we're printing in the serial port down here the commands that we're getting 10 and 11, depending on what we're getting for it working and not working, and turning the laser on and off depending on the command we get. So we get the command from the module, and as long as the command is something, then we're doing something with it. So that now makes sense to me. I understand how that works. I'm not going to play around with any of this code because I don't know enough about it. But in theory, I could change that to do something else with a different command, as long as the command is part of that list that's on that other page, which I'll go back to now. It will recognize, apparently, open and close the door, window, light, laser, and color light. So yeah, actually, I will change it up a little bit. I shall change that to color light, and as such, change the code. So I need to change that to color light. On is 12, and off is 13. So let's upload that, and then we'll try that and see if I can turn the color lights on and off by saying, I'll have to say open the color light. We'll see what happens there. So that's now uploading and writing. 100%. It's all gone through okay. Good, because sometimes when I change the code, it doesn't work. But that seems to be okay with that. Let me turn on my mic, see that you can hear it, and we'll see what happens. So if I say, hi Lumi,
Hi, what can I help you?
open the color lights.
Okay.
It's 12, but it's not actually done anything. Oh, the laser's come on again. Because I didn't change that. Close the color light.
Okay.
So, yes, I understand what's gone wrong there. I didn't tell it to do any different. I just left it on laser. But I did change the text, so that's okay. So if I now say, open the laser.
Okay.
It says okay, but doesn't actually do anything. So close the laser.
Okay.
Turn on the lights. Open the lights.
Okay.
Close the lights.
Okay.
Yeah, I'm getting the different numbers coming through on the serial monitor
See you later.
for the different commands, which is all I could really hope for without changing everything. Then I understand why it's doing that. So I'd need to change the thing from laser to everything else that, whatever. But I'd have to work out what number it is to turn the different lights on and things. So I'm not going to do that. But I understand that and know why that works like that. So that's okay. I'm happy with that now. So we'll go straight on to day 14. Try something new. Since you can open and close the Guardian Shield by voice, why not open and close the doors and windows by voice? Add instructions for opening and closing the doors. Yes, so this is going to add it all in. So yeah, I'll just reload that. Getting the servos set to certain angles first of all. I can't wait to try it out. Yeah, so we'll do that. Open the door. See how that works. Right, let's upload the code, upload it to the thing, and try it. Right, I have uploaded it. I've had to plug in a different battery because it wasn't working before with the other one, but that seems to be on and seems to be working. So let's try. Hi, Lumi. Hi, Lumi. Close the window. Open the door. Cool. Yes, again, power issues again, but it works and does the things. So yeah, let's have a look at the code and see why it does the things. And we'll go from there. Let me unplug everything for now while I'm sorted out. So the code is back here. It's exactly the same as it was before, but with extra bits. First of all, we're setting the servos to their closed positions, which is fine. Initializing voice recognition again. Yep. And then if it's greater than 0, then print what it's doing. And then, right, so if it's 2, we're doing that door. If it's 3, we're closing the door. If it's 4, we're opening the window, or the other way around. I can't remember which one's which. No, 17 and 18. But yeah, that makes sense to me. I understand that. And the servos just seem to be drawing a lot of power. So I seem to be going through batteries quite well. I didn't use very good quality batteries to begin with. But that makes sense to me. I can understand how that's working. So yeah, good things. Right, let's move on to the next step. And that next step is in fact Wi-Fi. So let's see how we're going to do that. Stand in the doorway and call for the smart voice when there's no response. Yeah, we're too far away from the smart voice. Is there any other way? Yes, we can use Wi-Fi. So the board has got Wi-Fi capabilities as well. So we need to connect that to my Wi-Fi with a passcode and the SSID, the something identification number, serial identification number. I shall get that connected up and then test it and then put in the code to do that. So yeah, let's see about getting that connected up and see what happens. I think I've figured out all of that bit, and we can turn the LED on and off by typing it into the address bar, basically. So right, let's figure out the code and upload it. Okay, I've got that up and running. So now I have that non-secure website 192.168.0.66, and by going to that website I now get the control back from that saying hello, which is all I really programmed it to do. But if I do now add to that and type slash LED underscore on, that should turn on the LED. And indeed it has done. I know you can't see that at the moment. There you go. The back LED is now on. And if I change that to off, press enter, that turns it off. Although it is connected, it's only connected through for power. In fact, it doesn't need to be connected. I can unplug that. So this is now an autonomous unit, but connected through the magic of Wi-Fi. If I put on again, nothing happens. Okay, that wasn't what should happen. LED on. I was trying to load it up. It might be a power issue. I think my batteries are dying. Try plugging that back in. Right, that's the LED on. Let's try turning it off. There we go. So yes, it does work when the power is working properly. Now putting on and press enter. It turns it on. Not connected to the computer at all working through Wi-Fi. So that works as intended. Just by changing text there to off and on. Good stuff. That was exactly what that controlling the LED light in the browser. Good. Task 16. Wi-Fi can also control doors and windows. I'm not going to do that because I know my power is going to go out when I try and control servos from it. But yeah, it's just by putting in a different control, door on, door off, will activate the different servos. So that makes sense to me. I understand how that works. And then there's the app. I haven't been able to get the app to connect, but I will try it again and let you know what happens. I'll show you the app anyway, but I'll try and get that connected. I've not been able to get it to connect through, but let me try that again and we'll see what I can do. Okay, so I have caved and done something I've been meaning to do for a while and picked up a small bench power supply, which I can set to any voltage I need. So I put it to 9 volts or thereabouts. It's actually a little bit less. There we go, a little bit more. 9.01. 993. There we go. 901. That's as close as I'm going to get to 9 volts. You can't really see it. There you go. But that's something I've been meaning to pick up for a while. This one comes with the normal plugs on it, although it actually comes with some different plugs as well, and lots of different connections, which is very useful. A lot of these, the bigger versions that I was going to pick up, don't actually come with the connections like that. They only come with probes, which are not terribly useful for me. But for this, yeah, all sorts of terminals. You could connect up probes on that one. But all sorts of different size plugs. But the one that connects into these is actually the right size for my board. So if I just plug that in, I know you can't actually hear that, but it said, "Hi, I am Lumi. Welcome to my smart home," and is working and should now connect through the app. Yes, I've been able to get the app to connect as well. I haven't been able to get that to connect properly before, but I think using the power supply is obviously cutting out another variable of possible batteries not working. So our app for the smart home, it is just the smart home one that I've used. The app does lots of things. This is the same app that I use for my quadruped robot, but for the smart home, we just clicked it there, and it should in fact be connected. Yep, there we go. So I can turn the light on and off with the push of a button. I can open the windows and the door. Let's tip it up that way so I can see the door. There we go. Door opens and it stays open as long as you like until you click close. And then it closes. Exactly the same for the window. The window is open. We can close the window. Open the window. The laser will go on and off as well, interfering with the camera there. And finally, the RGB down the bottom there. We can turn on, and using these sliders, we can adjust the color to any color you like. So if we just turn on the green, it becomes green. If we turn up the red and the green, get yellow. Turn off the green, it just goes to red. Red and blue, obviously any mix of them to make pretty much any color you like. Quite useful on that. What have we got on here? We've got light toggling on and off with a switch. I don't know what light that is. Turn everything off a minute. Light. Oh, that's the light sensor. So it's now giving us a reading over there, 494. There we go. You can just about make out on that. Light sensor reading is very low, then goes even lower when it's in the bright light. So let's turn on all of the sensors. There we go. Oh, human is the detecting, which will go to 1 when it detects movement. Raindrop obviously is 0 or 1 depending on if it's got any raindrops on there. There we go. Oh, no, it's not just an on and off. That does give us a reading. So that 2526 should go down. Yeah, there we go. As the water evaporates, that will go down. So we could then use this information to set that to a particular variable number. And it's giving us a live reading of the temperature and the humidity as well. 20 degrees, a little bit cooler. Why does that shut the window? Open the window because the raindrop sensor has detected less rain. So if I get that wet again, that should, yeah, automatically close the window. And the RFID is still working on the door. Opens it up and closes it after a few seconds. Good. And the voice activation works as well. I know it probably won't be able to hear it talk, but you can see the results. So if I say, "Hi, Lumi." Hi, Lumi. Not working now. Hi, Lumi. There we go. Open light. Close light. It doesn't like turn on and turn off for some reason. It's obviously my, there you go, the window's just opened itself again. It doesn't like my wording or my accent for doing things. So what can we do? The only other thing that happens is the button, which seems to turn on both the laser and the time portal thing, or indeed turn them off as well. So everything is working properly as intended. The app is working nicely as well. It's giving us numerical values for the RGB down there as well as showing it on the slider. So yes, that is the kit. She has just said, "See you later," because I hadn't said anything for 30 seconds. But yes, all of the problems I was having with bits of it before were power related. So yeah, if I wanted to have this running as a permanent thing, I could just leave it plugged in. Not plugged into the computer. The 5 volts from the USB is obviously not enough to power the servos. The other bits of it, no trouble at all. But now I've got power for it. That will work properly. I should get my power supply mounted somewhere on my bench out the way. So I've got that to plug into whatever I need to plug it into now, which is always good to have. So thank you very much for joining me on this build. I hope you've enjoyed it. And I hopefully, it's certainly given me a few ideas. Not sure about the voice recognition bit. That would be ideal. I've got the Home Assistant, obviously, to do things. But if I was to wire up other things to it, then I can run it off of a board, which is very nice to be able to do. So the voice activation things would be nice to have working because I like to be able to talk to things. Here we go. So for now, that is that for that. If you want to see more of this sort of thing, then leave me a message, leave me a note, send me a message, leave a comment, and let me know. Other than that, I shall see you for more builds very, very soon. So thanks for watching. See you soon. Bye bye.